My dear friends and dear Professor Karakaya, welcome to our presentation of our dataset selection and initial presentation. I am Galip Ankaya from Mechanical Engineering Department, and our team members are Aysu İrem Adem from Software Engineering, Roshna Sarıkaş and Tan Öktenay from Computer Engineering Department, and Rıza Umut Yurdagül from Electrics and Electronics Engineering Department. Today we will introduce the selected data set that we can make our project. In this presentation, we will talk about description and aim of our possible project, and we will continue with information about data set. Then we move on with the possible methods and techniques that we can use. And finally, we will mention possible customers. Our data set is about scheduled flights, which is flight price prediction. Traveling by planes is known as safest and fastest transportation type, but it is not easy to purchase tickets for everyone. On the next part of the presentation, Roshna will give some information about possible projects.
Hello, I'm Roshna. The problem addressed by using this dataset is the prediction of flight ticket prices. Flight ticket prices are influenced by various factors such as airlines, travel classes, departure arrival times, duration, and the number of stops. With this dataset, we can build a machine learning model to predict the ticket prices, which will help individuals compare ticket prices and choose the most affordable option for their travel plans. Next slide, please. It will also aid airlines in optimizing ticket prices and understanding the factors that affect ticket prices, thus making air travel more accessible to a broader range of people. Additionally, the dataset can provide valuable insights into market trends and consumer preferences, which will be useful for the airline industry in this strategic decision-making. Therefore, predicting flight tickets prices is an essential problem that will benefit both individuals and the airline industry, making air travel more accessible and affordable. Now, Aysu will give more detailed information about the dataset and features.
Thank you, Roshna. Now I'll continue with the information about the dataset. This dataset is selected on Kaggle.com as flight price prediction. It's created by Shubham Batwal. Octopus scraping tool was used to extract data from the website. Data was collected in two parts, one for economy class tickets and another for business class tickets. The data contains 300K distinct flight booking options and 11 features in the clean dataset. They collected data from easemytrip.com and possessed 50 days of flight traffic between 6 large cities of India. Next, please. We have 11 features. First, the airline, the name of the airline company, the flight code, the city, source city from which the flights take off, departure time, the time period which the flights take off, stops, number of stops between the source and the destination cities, arrival time, time period during the which the flight arrives, destination city where the flight will land, and the seat class like economy or business. These were all categorical features, and the numerical ones are a duration, the overall amount of time it takes to travel between cities in hours. Days left, the number of days between the booking date and trip date. And the price is the target variable that stores information on the ticket price. The features are interrelated with some features such as source and destination cities, departure and arrival times, and number of stops having a direct impact on the price of the ticket. Since it is important to check for missing values in the dataset as it can affect the accuracy of the analysis, the dataset has been cleaned and pre-processed, and there are no missing values in the dataset. Thank you. Now Tan will continue.
Tan, you do not activate your voice. We cannot hear you.
I'm sorry. You can hear me now, right?
Yes.
Yes, we can hear you now.
Thank you, Aysu. My name is Tan, and in the continuation of our presentation, I will tell you about the technical parts and feature distribution of the model using Orange Tree. Our project is an example of supervised learning. This is because the dataset consists of labeled data, as I mentioned, airline, departure time, stops, etc. With each observation having a known price value, our goal is to use this labeled data to train a model that can accurately predict the price of a flight given its other features. Furthermore, the output variable in our example is the price, is continuous, which means that we need to use regression model to make predictions. A regression model is a type of supervised learning that is used for predicting a continuous variable. I used Orange Tree to monitor feature distributions. On the right, you can see the widgets, data info, feature statistics, box plot, scatter plot, and distributions. Next, please. In the first plot, I put screenshots of some features with box plot widget. So here we can observe that Vistara has the most flights among other airline companies. Source city and departure time were almost evenly distributed. And lastly, you can see the most of the flights have one connecting flight. Next, please. Moving on to the scatter plot, we put airline on x-axis and price and on y-axis to show that most of the expensive flights are in Air India and Vistara. Other airline companies are under 40K Indian rupees. Next, please. Finally, we wanted to plot the price distribution with the distributions widgets. In the dataset to be used, most of the prices is between 0 and 20K Indian rupees. I also added the black line with the fitted distribution feature on Orange Tree. Overall, this flight prediction dataset provides a great opportunity for machine learning students like us to build a prediction model for the price of airline tickets. That was it for my part. Now Reza will continue with the conclusion.
Next, please. Tane already explained this page. So to conclude our presentation, we thought about how to use the analyze data and what kind of analysis we do for what kind of work. So we make a research about the Indian individual how to say customers which likes to use planes. So I'm so sorry, I got so nervous. So me and my team members make research about how do we use the analyze data which we plan to analyze, and we come to three main possible customers: the airline companies, tourism agentas, and online travel companies. There are some mobile apps for all of these possible customers, and they give their customer which kind of price they can take from which flight companies, but they don't give you the right time, the possible right time to give to buy the ticket for the most budget friendly time. So we are planning to analyze data and tell the information to these companies to make a better selling strategy. So thank you for listening.
Okay, I have several questions. First of all, that thank you for the good presentation and it is material. It looks like very professional. Thank you for that. It's good. Can you go to the first three slides, please? In the first three slides. Okay, please, next slides. Here. There are 11 features, right? In the next slide, please. Now, did you check that all the combinations of the from source city to the destination city, are there flight information, price information?
Yes.
Did you check that? From
Um,
all source city to the all destination city, there are samples.
I
Price.
can answer that
Yes, please.
question. In some flights, there are some transformations to one flight to another. So
Connected flights? Connected flights, you mean?
yeah, connected flight. Yes, there are some connected flights, but they don't specify in the data which companies are using the connected flights. They just in the data it just write two connections have been made or two or more connections have been made. So there is no specification for that information. If there is a connected flight, it writes it makes two connected flights or two or more connected flights.
Okay, but my question is basically, for example, in source city, if there is, for example, Istanbul, Ankara, Izmir, in the destination city, if there are Diyarbakır, Erzurum, Ağrı, are there all the combinations from source city, Istanbul, Erzurum, Istanbul, Ankara, Istanbul, Diyarbakır, İzmir, Diyarbakır, İzmir, Erzurum, İzmir, Ankara. Are there all possible combinations in the dataset? Did you check this? If some of them they don't exist, then in the prediction time, what you are gonna predict because you don't have these samples.
I don't specifically check that information, but the data, since the data has been gathered from the real flight.
Yes, they could be gathered like, but if you check, maybe you notice that from some source, there will be no flights to some destination. Then you can delete these source information from all the dataset samples. Do you understand my point?
Yes.
So, and another question, for example, departure time. In some slides, 5 slides later, you show some departure time range. Can you go there? Here, just, yes. The previous slide. Yes. Here, what it means, afternoon, early morning, morning. So these are all well distributed, looks like balance, right?
Yes.
So it is good then, because you can, but if some, for example, in the night, for example, there wouldn't be any flight, then maybe you just delete all the night flights from your data set. And you would also say that we don't take consideration into the consider the night flights. Do you understand my point? But here,
Yes.
please check these the destination and the source connections. If they are enough samples, it is okay. Right?
Okay.
Okay.
And
Teacher, can I ask a question?
let me finish first if you
Okay.
want, right? So if you go one back, two back slides, one more. Here, is there any day information? Which day of the week?
No. Because
It's very
this
important, right? Saturdays,
yes.
Fridays, weekends, holidays.
For that we got days left when we don't have the specific like 23rd of February like information. On this data we only have days left to that flight. Like if it's 1 day left, it's gonna be expensive, but it's like 30 days left, it will be more viable.
And there is the price as well. You would like to predict this, right?
Yes.
Can you
And
show
also
the price range? What are the price range?
it's
How
between
it's distributed? I mean, how it's distributed in two
yeah,
slides?
it's on the last slide. You can go next. Next one. Next one. Here it is. Most of them is around 0 and 20K. So this is not exactly balanced. But we thought that we have 300K samples. So if we have to drop some samples for the balancing, we can remove some samples around 0 to 20K.
Okay, why didn't you try any scatter diagram to see the prices or something, or the box, you mean here the box plots? I couldn't see any box plot here.
Box plot is in the two previous.
Okay, please check them. So ensure that you have some relationship with some features with according to the price of the ticket, right?
Okay.
And there are some outliers as far as I see in the price list. Next slide, please. So the other one. Maybe you need to delete the prices more than 80,000, whatever the dollar,
Yes.
whatever. Although
Yes.
you said zero, I think you said zero price, something like that. Maybe you would like to delete these, drop these information as well. I think they look like outliers. Please check
Yes.
the concept of outlier. Okay.
Okay. We thought that there's no zero price, by the way, in this graph. I just said it's between 0 and 20K. But you're right. We thought about the I mean, after 80K, we can delete that outliers to be to get a balanced price feature.
Okay. Secondly or lastly, you can think about changing this regression problem to a classification problem by using binning. So you can set up some range of prices like very cheap, medium, expensive, very expensive kind of ranges. Now you can try to classify or predict these price tags. Do you understand my point? It could be
Okay.
much more successful than I believe.
So you're saying that we put labels like, for example,
you can say that between 0 and 2000 is very cheap. 2000 between 5,000 is cheap, or more than 60,000 is expensive, very expensive. So you can define some ranges, then using these ranges, label the data, then predict the ticket price as expensive, cheap, very expensive, medium. Do you understand?
Okay.
It could be another use case. All right?
Okay. Thank you for the feedback.
Okay, Galipan, what do you think of that? Do you think that you can use the binning approach?
I don't know too much about binning, so I have no idea about that now. But I will
last hour
try
we
to
discussed
learn.
in the last classroom, we discussed this binning. How to convert continuous data to discrete data, right? We discussed actually. Okay. There is one question from the audience. Eray?
Teacher, I was actually going to ask if they have the data, because, but you did ask it.
Okay.
Actually, it's really important when deciding the price, if it's weekend or holiday time,
Yes, I
one of
believe
the
so.
major factors.
I believe so. So that information is missing. Okay. And you have some machine learning algorithms suggested in the next slides. Could you show this slide? Yes. So here, you already mentioned about this, but I will ask when your presentation continues, when you conduct the project, I will ask you if random forest and k-nearest neighbors are suitable algorithms for that kind of problem, I will ask in next presentations. Be ready for it, okay?
Okay. That's why we just mentioned the names on this presentation, so we can present it in another presentation.
During the classrooms, we will discuss this kind of things in details. So what I expect you to implement or to explain whatever you learn from the classroom discussions and topics. All right.
Okay.
Okay, thank you for everyone. It's a very good presentation. It is concise and to the point. I hope that you will begin to fill in your project report from now on. Okay, don't wait until the last day. Just download from the Moodle and begin to fill in the final project report. Thank you. I hope to see you in the next presentation, exploratory data analysis, in which you are gonna detailedly explore your data, okay, by using Orange Tree tool. Okay. Thank you for the presentation. Thank you.
Thank you.
Thank you. Have a nice evening.